Hello students, so let us start with the next topic, that is interference and diffraction of light. In this lecture, first I will cover the theory part of this topic, and then after the theory lecture we will solve MCQs that have been asked in previous years Mhtcet exams. After that we will cover the MCQs given in the assignment sheet. So this will be the sequence that we are going to follow today, right? So let us start with the basic discussion about interference and diffraction. To understand the word interference of light, first you must know the concept of superposition of waves. What is the concept of superposition of waves? See, if this is a point in space where if the first wave reaches, okay, this wave is going to displace this point, in certain direction by certain value at certain amount of time, and that point is going to oscillate because of this wave. If the second wave reaches this point, so the second wave is also going to oscillate that particle, right? If the third wave reaches at this point, so even because of the third wave it is going to oscillate. Similarly, if n number of waves are going to reach that point simultaneously, then this point, what this point is going to do? So according to the superposition principle, this point will follow the vibration of each and every wave, means this point will vibrate because of this, because of this, because of the third, because of the fourth. In fact, this point will vibrate because of all n waves, but the resultant vibration, addition of all those vibration, will be the vector sum of all the vibrations. Means if the particle vibrates because of the first wave and its equation is given as a sine omega t plus alpha 1, because of the second wave it is vibrating with a sine omega t plus alpha 2, because of the third wave it is vibrating with the equation a sine omega t plus alpha 3. Now you can check that these are not the equation of waves, these are the equation of the particle vibrations. SHM के equation है ये, because we are talking about vibration of the particle. ये same particle first wave की वजह से it is vibrating because of this, because of second wave it is vibrating in this way, because of third wave it is vibrating in this way. Similarly, n waves की वजह से how it will vibrate? According to the superposition principle, it will vibrate as a vector sum of all these displacements. All these displacement का vector sum will be the resultant displacement of this particle. Normally we will deal with 2 waves maximum, sometimes 3, and all those waves will be vibrating such that the particle will move along same direction. मतलब ऐसे नहीं होगा ये फर्स्ट वेव का डिस्प्लेसमेंट ऐसे है, सेकंड का ऐसे है और फिर ऐड करो, ऐसे नहीं होगा. क्वेश्चन विल बी फर्स्ट वेव का डिस्प्लेसमेंट ऊपर है फॉर एग्जांपल, सेकंड वेव का डिस्प्लेसमेंट नीचे है फॉर एग्जांपल, देन फर्स्ट वेव का डिस्प्लेसमेंट 10 सेंटीमीटर अप है, दूसरे का 3 सेंटीमीटर डाउन है, देन नेट डिस्प्लेसमेंट विल बी 7 अप. ओके, so we have normally simple harmonic progressive waves along a single direction. So what is meaning of the first term, superposition of waves? Superposition of waves means at a point when n number of waves approach, the net displacement of this particle will be the vector sum of each and every displacement. हर एक का vector addition will be the net displacement. This is called as superposition principle. Now once you understand the concept of superposition principle, it is easy to understand that if first wave का crest आ रहा है यहाँ पे crest, and second wave का भी crest आ रहा है यहाँ पे, then in that case what will happen? इसका amplitude 5 है for example, दूसरे वाले wave का 6 है, दोनों का amplitude will get added, you will get a large amplitude, that is 11. But if it happens कि इस पहले का crest और दूसरे का trough आता है, in that case the amplitudes will subtract, means crest आता है मतलब first wave is taking the particle up, second wave is taking the particle down. In that case they will undergo destruction, they will cancel out, try to cancel out each other, so they will subtract in their amplitudes, right? So superposition principle के formula में if y1 is equal to a1 sin omega t plus alpha 1, if the first wave and second, this is not a wave, right? This is equation of that SHM of that particle. First wave की वजह से first particle is oscillating in this way, because of second wave the same particle is vibrating in this way, a2 sin omega t plus alpha 2. Then उस particle का resultant displacement is given by r sin omega t plus delta, where r is defined as under root a1 square plus a2 square plus 2 a1 a2 cos alpha 1 minus alpha 2. We have studied this formula in oscillations lesson, right? This is the resultant displacement of that particle. This is the resultant displacement of that particle, and if you observe it carefully, whenever you can clearly observe it, whenever this factor cos alpha will be maximum plus 1 होगा जब वो, तभी R will be maximum कितना आएगा, when it will be plus 1, a1 square plus a2 square plus 2a1 a2, R1 will be a1 plus a2. This is what we call constructive interference or addition. We add the amplitudes. When this cos factor will be minimum minus 1 होगा, in that case R will be a1 minus a2. This will be, we will call it as destruction or destructive interference. So first point, whether it is clear what is the meaning of superposition principle. Okay, so once superposition principle is clear and this formula is clear, we will move to the concept of interference, right? So I'll explain the interference of light wala part now. See, the second important part of this lesson, that is interference of light after the superposition principle. See, if I consider this is the first source of light, let us call it as S1, and this is the second source of light, let us call it as S2. Because of the first source, the waves are coming out from the first source. This blue line means constructive, blue line means crest, and this red line is trough. There is a crest, there is a trough, there is a crest, there is a trough, again crest, there is a trough. If I continue drawing this crest, trough, in this way, crest, and then red means trough. This is what I have drawn for the first source. Similarly, second source will also emit rays. So first, इसमें से crest was the first one. So I will draw crest over here. Let us say this is crest. This will be trough, crest, trough, then the crest, next one is trough. I will keep on drawing it now. Crest, trough, again crest, and then trough, again crest, and then trough. Now if you observe this pattern, you can see that exactly at the center, what do we observe? Blue color, red, blue, red are intersecting, right? So you can see that red, blue are intersecting. So exactly in the central region, you will see red is meeting, blue is meeting, means crest is meeting, and trough is meeting. That is constructive interference. Here you get a bright spot, or here you get the maximum amplitude. But over here, if you observe, this is red blue. In this way, red blue का combination, this is destructive interference. Similarly, यहाँ पे red blue का pattern आएगा, फिर से red का pattern आएगा, destructive, constructive. So basically what happens is, when two sources are kept close to each other, and from those sources if the waves are coming out, at some positions you will get completely constructive, in some position you will get completely destructive. हाँ, यहाँ पे क्या है, यहाँ पे डिस्ट्रक्टिव भी पूरा नहीं है, कंस्ट्रक्टिव भी पूरा नहीं है. फॉर एग्जाम्पल, इसका एम्पलीट्यूड 10 और इसका भी 10 है, तो यहाँ पे 20 एम्पलीट्यूड आएगा, यहाँ पे कितना आएगा 0, यहाँ पे कितना आएगा 0. बट यहाँ से यहाँ जर्नी में 20 का डायरेक्टली 0 नहीं हुआ, इट विल स्टार्ट डिक्रीजिंग 19, 18, 17, 16 अप टू 0. इट विल डिक्रीज ग्रेजुअली. सिमिलरली इट विल डिक्रीज ग्रेजुअली ओवर हियर एज वेल. This particular thing is called as interference of light. In interference of light, the energy is redistributed. Energy from dark bands is given to the bright, and dark ka energy decreases. Basically, the energy is redistributed, and we get the pattern of alternate dark and bright. This is called as interference pattern, and this is called as interference of light. Okay, so interference of light may, before we start with the actual experiments that are Young's experiment and Biprism experiment, first you must know what is the condition of this interference. What are the conditions of this interference, right? So interference of light में there are some basic requirements. Before we start those basic requirements, एक बार सुपरपोजिशन के अंडर we know that R का फॉर्मूला क्या है, a1 स्क्वायर प्लस a2 स्क्वायर प्लस 2a1 a2 cos अल्फा 1 माइनस अल्फा 2, ये फॉर्मूला है राइट. तो इसमें R मैक्स कब होता है, इट इज a1 प्लस a2, एंड R मिनिमम कब होता है, रिजल्टेंट एम्पलीट्यूड मिनिमम कब होता है, a1 माइनस a2. This is called as constructive, this is called as destructive. So conditions, what are the conditions for constructive interference? What are the conditions for constructive interference? तो constructive interference के conditions है कि phase difference कितना होना चाहिए, phase difference should be कितना होना चाहिए, phase difference, this will become +1. +1 कब होता है वो, 0, पाई, 2 पाई, 3 पाई. इसके लिए 0, then directly 2 pi, 4 pi, 6 pi. For this cos 0 is 1, cos 2 pi is 1, cos 4 pi is 1. You will get maximum resultant amplitude. Constructive interference का condition है phase difference का. Destructive interference के लिए phase difference का condition क्या होगा, pi, 3 pi, 5 pi, 7 pi, obviously odd multiples because उसके लिए cos is negative, cos pi is -1, so minus will create minus sign over here. So constructive and destructive के conditions में phase difference important है, and phase और path में क्या relation होता है, simple relation होता है कि one wave में phase difference इन दोनों point में कितना है, path तो lambda है, इनमें distance lambda है, लेकिन phase कितना है, 2 pi, so 2 pi means lambda. So any general phase मतलब कितना, 2 pi means lambda, so delta means x. Any general phase difference means x. Cross multiply करने के बाद you will get delta is equal to 2 pi x by lambda. This is the relation between phase difference and path difference. So अगर phase difference and path difference में question है, phase difference के values अगर ये है 0, 2 pi, 4 pi, 6 pi, 8 pi, तो x के values क्या आएंगे, 0, 2 pi मतलब lambda right, then 2 lambda, 3 lambda and so on. Whenever phase differences are this, we call it as a constructive interference, and when phase differences are lambda by 2, 3 lambda by 2, 5 lambda by 2, then we call it as a destructive interference. So interference of light में first thing that you must know is the conditions of constructive and destructive interference. Conditions for constructive interference are this, phase and path. These are the condition of path difference. Path. These are the condition of path difference. Phase, path. This is for destructive interference. This is for constructive interference. Once the condition of constructive destructive is done, what is the condition for steady interference pattern? Steady interference pattern के conditions. This is theory question given in the textbook. What are the conditions of steady interference pattern? There are some 8 points. I will just write down it quickly. First, both the sources S1, S2 जो लिए थे ना, they should be coherent. I'll just write down, then I'll explain. Monochromatic, equally intense. Fourth is narrow. Small d should be small, large d should be large. Should travel in same direction, and they should be 8 pointers, they should be polarized in same plane. These were some 8 points which were given in the textbook, and these are the conditions for steady interference pattern. Means if you want the pattern to be steady, clear, it should have a good contrast, then these points should be followed. Sources should be coherent, means they should have no phase difference or constant phase difference. They should have no phase difference, or they should have constant phase difference. They cannot have a fluctuating phase difference, otherwise there will be no interference pattern. Monochromatic, why the sources should be monochromatic? They should be of single color, otherwise you will get colorful patterns, colorful bands. Third is equal intense, दोनों का amplitude 10 एग्जाम्पल में लिया था मैंने. If I take 10 and 20, तो कंस्ट्रक्टिव के टाइम ऐड करते वक्त 30, लेकिन सब्ट्रैक्शन में डिफरेंस लेते वक्त 10. सो यू विल गेट ब्राइट बैंड, लेस ब्राइट बैंड, ब्राइट बैंड, less bright band. So you won't get a contrast. So it should be equally intense, मतलब amplitude should be same दोनों का. They should be narrow. दोनों source point source होने चाहिए. You cannot take a bulb, two बड़े बड़े bulbs, and in that case the whole screen will get illuminated. Small d should be small, large d should be large. What is the meaning of small d? We will discuss this later on. In Young's experiment, whenever we take two sources S1 S2, उनके बीच का distance जो है we call it as small d, and screen का distance जो है we call it as a capital D. This should be small. ये जितना छोटा more clearer the pattern will be, and this should be large. This distance should be large as possible. They should travel in the same direction. Obviously the wave should travel in the same direction, obviously it is, and they should be polarized in the same plane. This is the extra point that you must remember, so that addition ke time they will be in the same plane, so addition will be easy. Otherwise you have to take the components, so they should be polarized in the same plane. So these are all the points that you must know. Theory section hai ye, and once you complete this section, first part of the lesson, we will straight away move to two important experiments, Young's experiment and Biprism experiment. दोनों के लिए formula is same with slight variation in it. Okay, so just copy down this thing. We will move to the next section now. See, the next important section of this lesson is Young's double-slit experiment. We call it as YDSC actually, Young's double-slit experiment. और उसका advanced version is Biprism experiment. Biprism experiment. दोनों experiment में formula is same, that is bandwidth is lambda d by d, और lambda is equal to cross multiply करने के बाद dx by d. Both the formula are same, actually rearranging the terms. दोनों experiment के लिए we stick to this formula, right? We don't have to derive कैसे आया formula. We have to just understand the meaning. What is meaning of each and every term in Young's double-slit experiment? Let us check. Young's double-slit experiment में we take a source of light which should be narrow according to the rule. Then we take two sources जिनके बीच में distance should be as small as possible, and these sources should be very narrow. This is called as D. So this is D over here. What is meaning of capital D? Capital D means screen कितने distance पे रखी है, screen का distance is capital D. Small d, capital D, right? After that, the light that we are using, that is coming in उसका जो wavelength है, that is lambda. ये D ये distance है, ये lambda तो wavelength of light है, and because of that interference pattern is going to occur exactly center को you will get a constructive interference, bright band मिलेगा. Okay, the reason bright band मिलेगा because दोनों waves equal distance पे travel करेंगी, so path difference 0, phase difference 0, so constructive interference. लेकिन इसके बाद यहाँ पे destructive आएगा, dark band, फिर से constructive आएगा, फिर से destructive आएगा. So the meaning of X bandwidth is the distance between two successive bright or the distance between two successive dark bands. This is the meaning of X. So in Young's experiment, you must understand the meaning of these four terms first. Very simple. X, lambda, D and D. Now once you understand the meaning, these basic shortcuts you must remember. They are not shortcuts, they are basic concepts that you must know actually. If I ask you, this is central bright band, okay? This is called as CBB. Sirf B nahi, it is CBB, central bright band. What will be this? This will be the first bright band. और ये नीचे भी जो है, it is also first bright band. So कितने डिस्टेंस पे है वो सेंटर से? टेल मी. फर्स्ट ब्राइट बैंड x डिस्टेंस पे ऊपर है और ये बैंड भी x डिस्टेंस नीचे है. सो फर्स्ट ब्राइट बैंड कितने डिस्टेंस दूर होता है सेंटर से? सेंटर से x डिस्टेंस दूर होता है. सेकेंड ब्राइट बैंड कितने डिस्टेंस दूर होगा सेंटर से? तो ये फर्स्ट 1x एंड 2x. थर्ड ब्राइट बैंड विल बी एट 3x, फोर्थ विल बी एट 4x. सो आई कैन से nth ब्राइट बैंड is at distance nx from the center. Means if this is screen, this is center. If I ask you seventh bright band कितना दूर है? Seventh bright band is 7x, which is 7 lambda d by d, because you already know the formula of x. सो फाइंडिंग द डिस्टेंस ऑफ एनी ब्राइट बैंड फ्रॉम सेंटर इज इजी नाउ. हाँ, इसमें क्वेश्चन कैसे पूछेंगे कि इफ 7th ब्राइट बैंड और 3rd ब्राइट बैंड में डिस्टेंस कितना है, देन ऑब्वियसली 7th ब्राइट बैंड का डिस्टेंस सेंटर से 7x है, 3rd ब्राइट बैंड का 3x है, सो इन दोनों में डिस्टेंस कितना होगा 4x. सो दैट इज लॉजिकल, बट इंपॉर्टेंट स्टेटमेंट वाज व्हाट, nth bright band is at distance nx from the center, also valid over here. Okay, similarly if we talk about dark bands, nth dark band कितने distance होता है. See, first dark band का ही observation ले लो. First dark band is not at distance 1x, it is at half x, that is 0.5x. correct, because x तो bright to bright है और center bright ही है. What is the distance of second dark band? Second dark band सेंटर से ये पूरा 1x है और ये हाफ x है, सो 1.5x पे है. सो फर्स्ट डार्क बैंड 0.5x पे है, सेकेंड डार्क बैंड 1.5x पे है, थर्ड डार्क बैंड 2.5x है. सो एवरी टाइम माइनस हाफ करना है. सो nth डार्क बैंड इज एट डिस्टेंस n minus 0.5x फ्रॉम सेंट्रल ब्राइट बैंड. This is second important point that you need to remember in Young's double slit experiment. So randomly question could be in this way, randomly कि सेंटर से 8th ब्राइट बैंड ऊपर और दूसरे साइड में 6th डार्क बैंड, इनके बीच का डिस्टेंस कैलकुलेट करो. हाउ विल यू कैलकुलेट इट? डिस्टेंस कैन बी कैलकुलेटेड एज 8th ब्राइट बैंड मतलब 8x, 6th डार्क बैंड मतलब 5.5x, एंड आंसर इज 13.5x. x का value, this data will be given to you, dd and lambda, so you can find the distance between these bands, but for that you must know this basic, that how to find the number of band का distance from the center. okay, so अब इसमें और variation क्या है देखो. in Young's double slit experiment, now we know this formula, we know the formula of Young's we know the formula of bandwidth, x का formula पता है, everything we know now. सो उसमें ही वेरिएशन देखो. सी, x का फॉर्मूला है लैम्बडा डी बाई डी, करेक्ट. व्हेन दिस x विल चेंज व्हेन देयर आर 3 पॉसिबिलिटीज. फर्स्ट पॉसिबिलिटी इज इफ आई चेंज द सोर्स इटसेल्फ, लैम्बडा सोर्स ही चेंज कर दिया, मतलब रेड लाइट था, रेड कलर के बैंड्स थे यहाँ पे, करेक्ट, रेड कलर के बैंड्स, आई चेंज द लाइट टू वॉयलेट, I'll get violet color के lights bands. So when I used red light, different bandwidth, x was different, XR था वो. अब violet light use किया तो bands अलग हो गए. Whether band size will increase or decrease, that is obviously easily calculate, you can easily calculate it, as it is directly proportional to lambda. Red से जब when you will turn to violet or blue, you are decreasing wavelength, so x will also decrease, right? So x will decrease means छोटे छोटे बैंड्स बनेंगे. So in this question remember, when colors are changed directly proportional है wavelength को, so बैंड छोटे छोटे होते हैं. In some questions ऐसे भी पूछ सकते हैं कि 10th bright band of red निकाल दिया, अभी ब्लू लाइट डाला, तो 15th bright band of blue coincides, दोनों का पोजीशन सेम है, उसी पोजीशन, सेंटर का तो पोजीशन सबका सेम होता है, सेंटर का पोजीशन इज सेम, बट 10th ब्राइट बैंड ऑफ रेड and 15th bright band of blue are at the same point, then what is the relation between their wavelengths? It is easily, you can calculate it. You know what is the distance of 10th bright, right? What is the distance of 10th bright? 10x. लेकिन रेड के लिए वो, एंड सेम डिस्टेंस किसके लिए है? 15 xb के लिए, ब्लू लाइट के लिए. सो फ्रॉम दिस यू विल गेट xr by xb is equal to 3/2, correct? 3/2. And once you know this, using this relation I can say lambda red upon lambda blue is 3/2. एक wavelength दिया होगा, you can find the second wavelength. So this type of questions, x change कब होता है? By changing lambda first. Second is by changing d. If you take the screen away, x will change, and by changing this small d, changing the slits. So x can change. But in चारों में x lambda d by d, in these four, the quantity which will not change easily is lambda, unless you change the light itself. अगर light source वही रखा, if I keep the same light, yellow color light, and if I'm just playing with this d and x, sorry, d and d, I'm changing this d and changing this d, what is going to change is x, not lambda. Lambda is the property of this source. Unless you change the source, you can do nothing. Many a times question will be in this way, lambda का formula ऐसे है ना. Many a times question will be, if distance is doubled, this distance is made half, lambda will become, it won't become 4 times, it will never change unless the source of light is changed. So remember this thing, light source पे depend करता है lambda. Okay, this is basic thing that you must know in Young's double-slit experiment. In Young's double-slit experiment, one more important point is, if the whole apparatus is dipped in liquid, what will happen? See, if the whole apparatus is dipped in liquid, remember the formula remains same. The only change will be lambda will become lambda dash now. So lambda will become lambda dash means what? Now liquid में lambda dash will be lambda by mu. Mu से divide हो जाएगा lambda. Means if air में wavelength use was 6400 और ये पूरा सेटअप वाटर में डाला जिसका रिफ्रैक्टिव इंडेक्स 1.6 है, तो वाटर में जाने के बाद what will be wavelength in water now? 6400 upon 1.6, that is 4000 angstrom unit. And this lambda you will put over here to find x. D and D will not change, right? Water में भी डाला तो भी distance same ही है. This distance is also same distance between slits. X will change because lambda changes. So inserting this whole apparatus in water, these are the changes that are going to happen. So Young's experiment मध्ये अजून काही variation नाही आहे. हाँ, अजून एक last point about Young's experiment is, if these are two slits and this is the source, this is the center, we call it as CBB. If I insert a transparent slab over here of thickness T, diffractive index mu, a small slab, glass slab, exactly in front of one of the slit, दोनों slit के सामने नहीं, only in front of one of the slit. Remember, the whole pattern shifts in the direction जिस direction में वो insert किया है. If I have inserted on the top, ऊपर वाले slit में, the whole pattern will shift up. कितने distance, central bright band अगर यहाँ आता है, by what distance it will shift? See, pattern का x fringe width will not change, same pattern का size, only the pattern will shift up. कितने distance से shift होता है, उसका formula क्या है? The formula is mu minus 1t into d by d. This is the formula of shift, right? By this value, the pattern is going to shift. Just learn this formula. Numericals textbook में है, इसके ऊपर एक one question is there. This is formula given in blue box of textbook. So you must know this formula. This formula is useful in case of Young's double-slit experiment. The next part is Biprism experiment. All the data is same. All the formulae are same. Lambda is equal to dx by d, dx by d. The only difference is measuring these parameters are slightly different. यहाँ पे distances directly you can measure physically. ये पट्टी लगा के ये भी you can measure using the scale, and x can also be measured using the scale. The problem over here is measuring these things is difficult. You cannot measure using a scale. These are measured using microscopes, or these are measured using those micrometer screw gauges which are inbuilt. Okay, for example, if you want to measure x in Biprism experiment, through that eyepiece we see these patterns. We see the pattern, dark, bright, dark, bright. How do we measure x? We place a cross wire on one of the band and then we rotate the screw, the pattern shifts down. After traveling n bands, if we traverse distance x, distance traversed, then what is x? X is how much distance you have traveled per band. How much distance you have traveled per band. For example, 20 सेंटीमीटर मैंने ट्रैवल किया, 20 सेंटीमीटर, उस प्रोसेस में 10 बैंड क्रॉस किए मैंने, तो हर एक बैंड के लिए 2 सेंटीमीटर ट्रैवल किया. सो दैट इज हाउ वी फाइंड द बैंड विड्थ. D will be given directly. D is the distance between the screen. यहाँ पे screen नहीं होती है, यहाँ पे होती है eyepiece, screen and slit. यहाँ पे होता है biprism. Biprism and eyepiece के बीच का distance will be this D. This D, to measure this D, we have to insert a convex lens. Now I won't go into the details of this, but this D can be measured using under root of D1, D2, where one is magnified image, other is the diminished image. Okay, so Biprism experiment, all the questions are similar to Young's. The only difference is the apparatus difference. You can just read it once in the textbook. You will understand how to measure these 3 parameters to measure the wavelength. So this is all about interference of light के दोनों experiments, Young's double-slit experiment and Biprism experiment. And after this, we are going to move to the next section of this lesson, that is diffraction of light. Okay, so the next part of this lesson is diffraction of light. Diffraction of light. What is meaning of word diffraction and what is diffraction of light? Basically waves. Diffraction is the property of wave nature, and diffraction means bending of a wave about obstacles or edges. Normally we see diffraction of sound waves, diffraction of radio waves, normally in day-to-day life. For example, if this is a room in which this is window which is open and there is a speaker over here, okay, emitting sound. Inside the room, if a person is sitting, then the sound waves will bend across the edges, about this edge, it will bend in this way, it will bend in this way, and finally it will enter the room. So this concept is called as diffraction. Whenever you see, suppose this is sound wave, and if there is an obstacle over here, okay, then the sound wave won't go straight like a light wave, that this part will be shadow. There won't be shadow of any sound, because sound can change its direction, it can diffract, and even sound can enter this region. This is called as bending or diffraction of a wave. Then why don't light wave do this phenomena? If you put light in this direction and there is a wall over here, you will see that light will only illuminate this particular region and there will be complete shadow over here. The reason behind this is diffraction of waves occur only when the size of the obstacle is in comparison, or it is comparable with the wavelength of the wave. Wavelength of the wave के size का obstacle होगा. In that case, the diffraction normally takes place. For example, sound wave 17 mm to 17 meter is the range that we normally hear. We hear this range of sound. 17 mm is 1.7 centimeters to 17 meters is very large. And normally day-to-day life में जितने obstacles है, that like a door or a window or a big mountain, everything generally they lie in this order of magnitude. So for us, normally sound wave ka diffraction, we are used to this type of diffraction. But the problem is when we are dealing with light, we are dealing in the order of 10 raised to minus 7. And so small obstacles of this order are very difficult to find. So generally we don't see diffraction of light. Naturally we don't see, because uska obstacle ka size should be very, very small. So normally light ka diffraction occurs, but it occurs very small. Directly we don't observe in day-to-day life. So to study diffraction, first of all, whether the meaning of diffraction is clear. What is meaning of diffraction? Diffraction मतलब bending. Normal waves bend होते ही है, लेकिन light waves, why don't they bend normally? Because उनका size इतना कम है कि उनके size के obstacles होने चाहिए. So if you have a very sharp pin, or if you have a razor blade का cutting edge, a razor blade का cutting edge, and if that razor blade का cutting edge, if I place a torch in front of it, you will find that razor blade का जो edge है ना, उसका जो shadow है ना, it will be a blur, because light will enter inside that shadow, inside that razor blade ka cutting edge, because it is so sharp that light will bend easily across it. So this is the basic concept behind the diffraction. Okay, so in case of diffraction, we have Fraunhofer's diffraction. Fraunhofer's diffraction, that is diffraction because of a plane wavefront. If this is a slit and if plane wavefront is incident, light का plane wavefront is incident, what do we expect? Screen के ऊपर exactly center पे bright and पूरा shadow, but reality में light bends on these edges and it enters in this region. To study that pattern, if you insert a convex lens and if you study the intensity pattern of this, what you will find is the intensity curve will be in this way. See, all the light that is entering will obviously converge at the focus. So यहाँ पे all the rays coming out from this will converge at the focus, so they will undergo constructive interference. In fact, this upper half and this lower half will undergo constructively, because उनके बीच में path difference is zero. Path difference is zero everywhere. So they will undergo constructive. So यहाँ पे maximum intensity मिलेगी. So intensity, if I plot on this curve, if I plot intensity versus position, I will get maximum intensity over here, and intensity का graph I will draw. It will be maximum. It will drop gradually on both sides. As you go away, intensity will drop, again increase, but this time you will get this type of pattern. Okay, you will get this type of pattern, and यहां पे दिस इज कॉल्ड एज प्रिंसिपल मैक्सिमम और सेंट्रल मैक्सिमम, राइट। बट ये एक मैक्सिमम छोड़ के और बहुत सारे मैक्सिमम है, सो मैक्सिमम का प्लूरल इज मैक्सिमा। सो दीज आर कॉल्ड एज विच पॉइंट्स, दिस वन और दिस वन और दिस वन, यहाँ पे भी 1 2 3, these points are called as secondary, these are primary maximum, these are secondary maxima, maximum का plural secondary maxima. अब we will talk about minimum. Is there a central minimum? There is no central minimum, central में maximum ही है. So all these points 1 2 and 3, यहाँ पे भी 1 2 and 3 are called as secondary minima. Minima is the plural of minimum. There is no minimums. Minima, right? So what do we call this point? This will be the first minimum. This will be second minimum. This will be third minimum. Similarly, first minimum, second minimum, third minimum. What will be this? This will be the first secondary maximum. Second secondary maximum. Third secondary maximum. Similarly, first secondary maximum, second secondary maximum and third secondary maximum. And if you want to find कि उनमें distances कितने हैं, then you must remember this curve. I will just draw that curve vertically over here now. For explanation purpose, I have drawn it over here in this way. But if you draw it, if you plot it in this way, see, central maximum I will plot on this and then gradually decreasing. दिस पॉइंट, ये जो पॉइंट है ना, ये यहाँ पे स्लिट थी, राइट, लेंस थी और स्लिट थी. ये जो पॉइंट है, हाउ मच एंगल इट इज मेकिंग विथ द वर्टिकल लाइन, दैट एंगल और एंगुलर पोजिशन आई विल राइट ओवर हियर. दैट एंगुलर पोजिशन इज कॉल्ड एज लैम्डा बाय, इट इज इक्वल टू लैम्डा बाय, व्हाट इज दिस, हॉरिजॉन्टल एक्सिस पे क्या है, एंगुलर पोजिशंस. दीज आर एंगुलर पोजिशन, दीज आर नॉट लीनियर डिस्टेंसेस. दिस इज एंगुलर पोजिशन. सो ये फर्स्ट मिनिमम हॉरिजॉन्टल लाइन से कितने एंगल पे होता है, लैम्डा बाय पे. सेकेंड मैक्सिमम, सेकेंड मिनिमम कितने एंगल पे होगा, इट इज एट 2 लैम्डा बाय, इट इज एट एंगुलर पोजिशन 2 लैम्डा बाय. सिमिलरली यहाँ पे माइनस लैम्डा बाय, माइनस 2 लैम्डा बाय, माइनस 3 लैम्डा बाय, माइनस 3 लैम्डा बाय. सो दिस आर द मिनिमम कंडीशंस, कंडीशन फॉर मिनिमा. एंगुलर पोजिशंस है. And once you have angular position, you can easily find the linear positions, means the linear distances. If I ask you इनके बीच में क्या distance है, what is the distance between this and this? So angular position तो you can find कि angle कितना है उनके बीच में. But if you want to convert into actual distance, how to convert? See, if you have this arc and if I say इन दोनों के बीच में angle theta है, इन दोनों के बीच में angle theta है, as well as theta is between these two and theta is between these two. Let us name it A, B, C, D, E, and all का radius is R. Tell me what is distance DE? You will say DE equal to R theta. कैसे आया R theta? S is equal to R theta. What is DB? DB कितना आएगा, 2 theta उनके बीच में एंगल है, so 2 R theta, 2 एंगल लिया, 2 theta into R. So what will be distance AE? Distance AE will be R into 4 theta. So very simple, angular position into radius or into distance will give you the linear distances. So now you can ask me distance between any two things. Suppose if I ask you third minimum और first minimum के बीच में कितना distance है. So angular distance कितना है, 2 lambda by a angular distance है, into radius करना है. यहाँ पे radius क्या होता है, radius is the distance of the screen from the center, that is called as capital D. So this will be the distance of third and first minimum. You can ask me anything. थर्ड मिनिमम ऑन राइट, सेकेंड मिनिमम ऑन लेफ्ट. तो थर्ड मिनिमम ऑन राइट मतलब 0 से थर्ड मिनिमम 3 लैम्डा बाई ए एंगल और सेकेंड मिनिमम 2 लैम्डा बाई, सो 5 लैम्डा बाई एंगल हो गया. इनटू डी किया तो यू विल गेट लीनियर डिस्टेंस, राइट. सो एंगुलर पोजिशन और दिस ग्राफ विल बेसिकली सॉल्व ऑल द क्वेश्चंस बेस्ड ऑन डिफ्रैक्शन, ओनली नोइंग दिस ग्राफ. हाँ, फ्रॉम दिस ग्राफ you must know how to convert angular to linear, multiply it with d. Sometimes this d will not be given. In that case focal length will be given, focal length से multiply करना है उस time. If d is not given, focal length is given, use the focal length का concept. And last point is if central maximum का विड्थ इज आस्क्ड कि सेंट्रल मैक्सिमम का विड्थ क्या है, तो वो तो दो मिनिमम के बीच में बैठा है, सो दो मिनिमम का एंगल कितना है 2 लैम्बडा बाय, करेक्ट, 2 लैम्बडा बाय इंटू डी किया तो यू विल गेट विड्थ ऑफ सेंट्रल मैक्सिमम 2 लैम्बडा डी बाय ए, दिस इज द विड्थ ऑफ सेंट्रल मैक्सिमम. So if you want to solve any question on diffraction, even in MCQ session, I will show you that diffraction वाले questions can be solved using this simple graph. एक graph draw करके you can solve all the questions regarding diffraction. Okay, so let us move to the last part, that is optical instruments. Okay, so the last part of this lesson, that is instruments, optical instruments, telescope and microscope. So first we will see about microscope and then we will see the formulae that are for telescopes. Okay, so in this we are going to discuss two important terms, limit of resolution in detail and then the resolving power. यहाँ पे भी first we will discuss limit of resolution. What is the meaning of limit of resolution of a microscope? First we will see, then we will move to telescope. See, if I have two microscopes, microscope M1 और ये दूसरा माइक्रोस्कोप है माइक्रोस्कोप M2. ये माइक्रोस्कोप ऐसा है कि दिस माइक्रोस्कोप विल शो मी टू बैक्टीरिया एज सेपरेट बैक्टीरियाज इफ दे आर 5 माइक्रोमीटर्स अपार्ट. अगर दो बैक्टीरिया 5 माइक्रोमीटर डिस्टेंस से दूर है, 5.1 है या 5 है या 5.2 है या 5.5 है, दूर है 5 से, तो दिस माइक्रोस्कोप विल शो मी दे आर सेपरेट. इफ दीज टू बैक्टीरिया आर 4.9 micrometer apart, this will show me two bacteria, they are sticking to each other. It won't show me two different, it will show me single bacteria, बड़ा वाला. It won't resolve it into two pieces, it will show me a single object. So ये जो distance होता है minimum distance, उसके नीचे अगर दो बैक्टीरिया आ गए, this won't be able to distinguish it. That distance is called as limit of resolution. So simple definition है, limit of resolution of microscope मतलब क्या? Limit of resolution of microscope is the shortest distance up to which two bacteria are shown separately or 2 point objects are shown separately, or 2 points objects are shown just resolved. ये word important है. Just resolved means उस distance के अंदर आ गए तो they will be unresolved. Unresolved means unseparated. And 5 के ऊपर तो they are separated, no problem. This is first microscope. दूसरे माइक्रोस्कोप का सीन अलग है. दूसरे माइक्रोस्कोप में वो दो बैक्टीरिया को अलग अलग बैक्टीरिया दिखाएगा. इट विल शो इट टू डिफरेंट बैक्टीरिया इफ दे आर 3 माइक्रोमीटर्स अपार्ट. मतलब 3 माइक्रोमीटर के ऊपर है, अगर वो बाहर है 3 माइक्रोमीटर डिस्टेंस से ज़्यादा है, दिस विल शो दे आर डिफरेंट ऑब्जेक्ट्स. इफ दे आर क्लोजर देन 3 माइक्रोमीटर, 2.9 भी होगा, इट विल शो इट एज अनरिजॉल्व्ड, अनसेपरेटेड. टेल मी विच वन यू विल बाय, विच वन इज परफेक्ट, विच वन इज गुड, विच वन of these two microscopes have more resolution? Obviously you will go with answer 2. Why this? Why second microscope? Because it is going into the details, it is resolving smaller distances as well. So अगर और भी पास होगा, तीसरा माइक्रोस्कोप अगर 1 माइक्रोमीटर तक रिजॉल्व करता है तो ये तो बेस्ट हो जाएगा इनमें. So limit of resolution, whether the meaning is clear, this is very simple meaning. Limit of resolution is the distance between two point objects for which the microscope shows them as separated. So limit of resolution, the formula is lambda upon 2 mu sin alpha. This is the formula of limit of resolution. D क्या है? डिस्टेंस है ना, इसलिए D यूज किया है, स्मॉलेस्ट डिस्टेंस है. सो इसका यूनिट क्या आएगा लिमिट ऑफ रेजोल्यूशन का? मीटर आएगा ना. यूनिट विल बी मीटर. लैम्बडा इज वेवलेंथ. 2 क्या है? 2 इज कांस्टेंट. म्यू इज रिफ्रैक्टिव इंडेक्स ऑफ दैट माइक्रोस्कोप विच इज नॉर्मली वी यूज इट इन एयर. सो एयर में यूज करते हो तो 1 यूज करेंगे, लेकिन ऑयल इमर्स्ड माइक्रोस्कोप होते हैं उनमें म्यू विल बी गिवन टू यू. एंड व्हाट इज अल्फा? अल्फा मीन्स वो जो ऑब्जेक्टिव लेंस होता है, ऑब्जेक्टिव लेंस बैक्टीरिया के साथ कितना सेमी वर्टिकल एंगल जनरेट करता है, दैट इज कॉल्ड एज म्यू. Sorry, that is called as alpha, semi-vertical angle. So how to calculate limit of resolution of microscope? Whether it is clear, it is wavelength of light that we are using upon 2 mu sin alpha. So this is how we can measure limit of resolution. अगर माइक्रोस्कोप का लिमिट, टेल मी माइक्रोस्कोप का लिमिट ऑफ रेजोल्यूशन शुड बी मोर और इट शुड बी वेरी वेरी लेस? जितना लेस उतना अच्छा है. सो वी ट्राई टू रिड्यूस दिस. हाउ टू रिड्यूस दिस? 3 स्टेप्स है. एक तो रिड्यूस लैम्बडा. सो ऑब्वियसली लैम्बडा रिड्यूस कैसे करेंगे? ये लैम्बडा तो लाइट जो अपन पुट करते हैं बैक्टीरिया पे बाहर से, सो सनलाइट पुट करते हैं, नॉर्मली इफ आई पुट रेड लाइट तो लैम्बडा उसका 6400 है, तो उससे बेटर है ब्लू लाइट यूज करूंगा मैं, बिकॉज उसका लैम्बडा इज लेस, सो लिमिट ऑफ रेजोल्यूशन और लेस, सो ब्लू लाइट से बेटर इट विल बी विजिबल. ओके, सो ब्लू लाइट्स विल रिड्यूस लिमिट ऑफ रेजोल्यूशन, सो ऑलवेज प्रेफर ब्लू ओवर रेड. सेकंड इज म्यू इंक्रीज करो, मतलब एयर में म्यू 1 था, सो इंस्टेड ऑफ एयर माइक्रोस्कोप्स वी यूज ऑयल इमर्स्ड माइक्रोस्कोप जिनका म्यू ज़्यादा होता है, सो इंक्रीज म्यू. एंड थर्ड इज इंक्रीज साइन अल्फा, मीन्स टेक अ बिगर लेंस, बड़े बड़े माइक्रोस्कोप जिनमें बैक्टीरिया विल मेक लार्जर एंगल एट द सेंटर, सो इंक्रीज साइन अल्फा. सो these are the ways of changing, these are the way of decreasing limit of resolution. Smaller the limit of resolution, better the instrument is. So this is the meaning of limit of resolution for a microscope. Similarly, limit of resolution of telescope क्या होगा, तो telescope में we observe objects which are far away. So telescope में it is not the distance, telescope में it is the angle. अगर दो स्टार 3 सेकेंड्स के एंगल से ज़्यादा बाहर है देन दे अपीयर सेपरेट स्टार्स, लेकिन 3 सेकेंड के अंदर आ जाएंगे देन दे अपीयर सिंगल स्टार. सो 3 सेकेंड उसका क्या हो गया, लिमिट ऑफ रेजोल्यूशन. एंड स्मॉलर द लिमिट ऑफ रेजोल्यूशन बेटर द इंस्ट्रूमेंट इज. सो उसका जो फॉर्मूला है वो है 1.22 लैम्बडा अपॉन 1.22 लैम्बडा अपॉन ए. इसमें 1.22 कांस्टेंट है, ये 1.22 कांस्टेंट है, वो सेल्फ ल्यूमिनस ऑब्जेक्ट है, इसलिए लैम्बडा जो है वेवलेंथ दैट इज कमिंग फ्रॉम इट, wavelengths coming from star, and d is the diameter of the aperture, diameter of the objective lens, diameter, aperture भी बोलते हैं उसको. d is the a is the aperture of the lens. So smaller this is, better the telescope is. So telescope को better कैसे कर सकते हैं, you cannot change 1.22, जैसे यहाँ पे 2 cannot be changed, you cannot change lambda, you can change lambda over here because lambda is the light that we are giving to the bacteria. यहाँ पे lambda क्या है, it is the light coming from the star which you cannot change. हाँ, उसमें there is a chance if you are observing for example a star which is emitting white color का light, then we will try to see that star in blue color, so that is better, blue में ज़्यादा उसका resolution आएगा. Third and the last point is A, that is aperture. Aperture, if you have a larger aperture, smaller will be the limit of resolution, which is better. So big telescopes are normally used so that limit of resolution will be as small as possible. And limit of resolution for microscope is in meter, वैसे telescope का limit of resolution is in radian since it is angle. And limit of resolution दोनों केस में जिसका reciprocal होता है that is called as resolving power. Resolving power of any instrument is reciprocal of limit of resolution. So this is all about the theory of interference and diffraction of light. We will continue with MCQ session after this.